Hello everybody, my name is Khang. Today I'm going to talk to you about constraint programming. As you all know, nowadays artificial intelligence is becoming more and more popular. You will hear terms like deep learning, machine learning, reinforcement learning every day. They are very well known in the field of AI. There are also fields that is less known to us, for example, constraint programming, which is I am working on. As a researcher of constraint programming, today I would like to introduce to you some basic concept about constraint programming. We will talk about the definition of constraint programming, how to solve a problem in constraint programming, and what is its real-life application. Okay, let's get started. First, what is constraint programming? Constraint programming is a type of programming that try to solve a constraint satisfaction problem, or CSP. CSP, according to Rina Detcher, in her Bible of constraint programming called Constraint Processing, she says that the CSP consists of two parts. The first part is a set of variables. A variable is an object that can take multiple values. Those values altogether is called the domain of the variable. The second part of a CSP is called a set of constraints. A constraint is a rule that the combinations of variable has to follow or has to satisfy, and thus we have the name constraint satisfaction problem. To understand more about the CSP, let's take an example. Let's say we have a 2x2 matrix. Each can be either 0 or 1. And then we know that the top left cell is 0. Our job is to fill in the rest of the square so that the sum of the first row, the second row, the sum of the two columns is 1. So in this example, our variables will be the 3 cells here that is missing value. Our domain will be 0 and 1, and the constraint will be the sum of each row and column is 1. Okay, how can we solve this problem using a CSP, using constraint programming, or how can we solve a CSP in general? We have two methods. The first method is called trial and errors. In trial and errors, what we did is we repeatedly and systematically try every combination of values for those variables until we found a correct solution or we run out of combinations. Okay, let's get back to our example. For the convenience, let's say this cell is called B, this cell is called C, and this cell is called D. Then we can try our first combination. Let's say B equal to 0, C is equal to 0, then D equal to 0. Okay, the square will become 0, 0, 0, 0. Is it a solution? No, because the sum of the first row is 0, not 1. Okay, we move on to the next combination. Let's say B equal to 1. Our matrix become 0, 1, 0, and 0. Is it a linear solution? No, because the sum of the second row is 0, not 1. We keep trying until we hit this combination. B is equal to 1, C is equal to 1, and D is 0. Then our matrix become 0, 1, 1, 0. And it is our solution. The second method that we can try is called consistency check. What we do in consistency check is that we will eliminate all the combination of variable or the combination of value that we are sure not in our solution. For example, in this example we say, let's look at the first row. We know that the sum of 0 and b is 1. So b has to be 1. b cannot be 0. Look at the first column. The sum of c and 0 is 1. So c also has to be 1, not 0. Now let's look at the second row. c plus d is 1. We know that c is 1. So d has to be 0, not 1. And this is our solution. In reality, some problems will be very complicated. They have very large number of combination. So trial and errors take a lot of time. Some other problems, consistency check doesn't work because we don't have enough information. So what we can do is to combine all two methods together, so we have better time solving CSP. Now, after we already know how to solve a CSP, but how can we apply it into our real life situation? One of the most famous CSP problem is called a Sudoku. In this Sudoku, you have to fill in the 9 by 9 matrix with number from 1 to 9, so that the value of each row, each column, and each 3 by 3 block are different. So the variable here will be 81 cells. The domain will be from 1 to 9, and the constraint will be the row of the value of each row, columns, and 3 by 3 blocks are different. Another example, which is more familiar to college students, is a 4-year plan. In a 4-year plan, what we did is we have to come up with what class we want to take for each semester, so that we can graduate, like meeting all the requirements for graduate. So our variable can be the slot that a variable for each semester. The domain will be the classes offered by UNL, and the constraint, it can be the requirement for graduation. It can be what classes you like. It can be the availability of each classes, like some class already offered in some semester. It can be the prerequisite, like you have to take class math 100 before taking math 200. So if we can find a solution to that CSP problem, then we can construct a 4-year plan. And if you guys strictly follow that 4-year plan, you can take all the class you want, all the class that you like, and also meet the requirement for graduation. To sum things up, I've just introduced to you the basic concept of CSP and how to solve it, and how we can apply a CSP into our real life situation. As AI become more and more popular, so is CSP or constraint programming. There are a lot of job opportunity and research opportunity out there. If you want to know more about them, feel free to come and talk to me and we'll discuss about them. Thank you for your listening.